Well, hello and welcome to this exercise, this revision exercise rather, on graph application and interpretation. It is based on an iGCSE question here, and therefore suitable for 11th grade algebra. Right, we have the table shows values of the variables x and y. Okay, then it says uh, using the graph paper below, I'm going to show you the graph paper. I'm going to show you the graph paper later on. So using the graph paper below, plot a suitable straight line graph to show that for x is greater than or equal to 10 degrees and less than or equal to 80 degrees, show that the square root of y is equal to a sine x plus b, where a and b are positive constants. And the next one says, use a graph to find the value of a and of b, where a obviously is the gradient of the straight line graph, and b is where the graph crosses the y-axis. Okay. The table says estimate the value of y when x is 50. So we're going to find sine of 50 and then find the square root of y and then square that to get y value. And the fourth one is the reverse of the third one. This time around we know the value of y, and then we can from that find the value of x. Now, looking at this one here, the best accuracy you can get is to 1 decimal place, really. So your answer hopefully should be up to 1 decimal place. But we got enough space in the graph to be able to plot values of up to 2 decimal places at least. So now what I've done is to produce this table here. Now I plot my these are the given x values, and from that I'm going to plot my sine. I'm going to find my sine x values, which are in column 2. Okay, having found sine x, and then using y, I'm going to find the square root values of the respective y values, and that's what we got there. Right, now this is the table we had from the last slide. Now what I'm going to do is, now you don't have to do this in the exam, is now to produce reduce this 4-column table to a 2-column table of sine x and root y. Okay, now I'm going to produce 2 of these, one showing 1 decimal place and the other showing 2 decimal places. Now it's up to you which one you use, but I prefer to use the 2 decimal place and then at the end approximate to 1 decimal place. So for 1 decimal place we've got this one here, and for 2 decimal places we got this one. Okay. Now, as I said, you don't have to do this in an exam. Any one of these will do, but I prefer this one is better, I think, because it can then approximate to 1 decimal place. Okay. Right. This is a graph given to us. Okay. And I can see I've actually started from 2.96. That value there should be 2.96 on the y-axis, 2.96 there. So that goes up in 0.4. So that's 3.0, 3.4, 3.8, 4.2, and so on. So each of these is 0.4 on the y-axis. Okay. Now similarly, for on the x-axis, I got 0, 0.2, okay, and 0.4, 0.6, and so on. Now what I then do is to use the second table here, this table here, to plot my points as far as I can get. I've done this by hand, so it's not very accurate. the joy of this type of question is that you have for each answer you have a lower value and an upper value. So as long as you're within that range, you should be okay. Right. My first point is this one here. Okay, that will be the 0.17 and 3.34, and the second point will be 0.5 and 4, which is that one there. And the third point is this one. And the fourth point is this one here. And the fifth point is 0.98 and 4.97, which is 9.5, which is that one there. Okay. Now we draw our straight line. We draw out those points as best as we can, as best as I could. And this is what I get. Okay. Now note here that this line intercepts the y-axis at the point there. And that point is 2.96. So our b value then becomes 2.96, and to one decimal place that becomes 3. So the answer for b should be 3 there. But it doesn't matter if you leave it at 2.96, but 3 is good enough there. Now for a, now to find a, we need to find the rise and the run. So first the run, that's our run, and then the rise, and that's our rise. So the slope, or the gradient is going to be rise divided by the run, and that's what we got there. So we end up with, because this is our rise here, which is 1.63, and this is our run here, which is 0.81, and that gives us an a value of 2.01, and to one decimal place that becomes 2.0. So the answer for a is 2.0. Now for the third question, or for the third part, we are given that x is equal to 50, and we want to find the value of y. So if x is 50, the sine of 50 is 0.766, which will give us a value right about there. And when you project a point from there to your graph, okay, and then back to the y-axis, we have a root y value of 4.5. So root y is 4.5, and if you square that, you get 20.43. Okay, so working to one decimal place, our answer should be answer y should then be 20.4. Should be our answer for that one there. Now for part 4, it says estimate the value of x. Now it says, don't forget here, it says estimate, so there's no one answer, so there's going to be a range of answers there. It says estimate the value of x when y is equal to 12. Now to find that, we want to find the square root of 12, and that gives us, the square root of 12 is 3.46. Okay, and then from 3.46, it's about here somewhere. That's 3.46. Okay, and when we move down to that point there, we get an equivalent value on the x-axis of 0.24. And if we then do the inverse of 0.24, we get that the angle in question is the inverse of the sine inverse of 0.24, get the angle in question is 13.9 degrees. Okay. And I hope all that made some sense, and please subscribe. Thank you for watching, and hopefully see you again sometime. Bye bye now.